So let's take a look at example 4. So again, we're factoring here. The only difference is we have cosecants and cotangents in this problem. So this would be like saying x squared minus y minus 3. Can we factor this? No. So we want to get all of our trig functions to be the same thing. So what do you think we can do?
Use the Pythagorean identity.
Use one of our Pythagorean identities. So the Pythagorean identity that involves cosecant is 1 plus cotangent squared u is equal to cosecant squared u. So we can substitute this cosecant squared in, well, we can substitute 1 plus cotangent squared in for our cosecant squared. Everybody with me so far?
Wait, so we can't do what we just did for the other one because it's two different.
Right. So we have to make it all the same trig function, which this trig identity is perfect because when we plug this in for our cosecant, it gives us cotangent. So then we're just left with cotangents in our problem. So then it would all be the same trig function and we can factor from there. So let's plug in 1 plus cotangent squared x minus cotangent x minus 3. What can I do to simplify this before I factor? Add like terms. So I have 1 minus 3, which gives me what?
-2.
-2. So cotangent squared x minus cotangent x minus 2. All right. So what can we do next to factor this? We can say that cotangent is x, so we have x squared minus x minus 2. Do we have two factors of -2 that add to -1? What are they?
One times -2.
1 times -2. So this becomes x plus 1 and x minus 2. What's the last thing we need to do?
Switch it back to cotangent.
Switch it back to cotangent. So we have cotangent of x plus 1 times cotangent of x minus 2. Any questions on this one? All right, we're going to do the next two examples tomorrow. So looking at our identity sheet, what should we do? What do you think? Is there a way we can get this all to be either sine or cosine? We got that cotangent in there. Can we change that to anything? You guys have your identity sheet in front of you? Perfect. We can change cotangent to cosine over sine. So we have sine of x plus cosine x over sine x times cosine x. Now I'm going to make this a cosine over 1 just so we don't get confused on if the cosines on the top or on the bottom, I'm going to multiply these two together. So we have sine x plus, what's cosine x times cosine x? So cosine
x squared.
cosine squared x, because it's the cosine that's squared because we have cosine times cosine. And then we just have a sine x on the bottom. Now, these problems are kind of tricky to see what to do next at first, but as you guys start to practice them, it gets a little bit easier. So is there any way we can combine this to be one term? So right now we have sine of x plus cosine squared x over sine. So any way we can combine these two together, can we add them?
Can't you add the sine x's together?
Well, think about this as sine x over 1. So we have like two fractions that we're adding together, but if we want to add these together, what do we need to do to them? What needs to be the
Multiply
same?
them both by sine.
Perfect. We need the denominators to be the same if we want to add them. So for the first one, I'm going to multiply the top and the bottom by sine x. So now I have sine squared x over sine x plus cosine squared x over sine x. Now can I add them?
Yeah.
Yeah, because my denominators are the same. So on the top, I get sine squared x plus cosine squared x over sine. Anytime I see sine squared or cosine squared, what should I look at on my identity sheet? So sine squared x plus cosine squared we can change to what? 1. So this is 1 over sine x. So we just substituted this in for 1. Can we simplify 1 over sine x? What's 1 over sine x? Let's go back to our... So what's our answer here? What's 1 over
Would it
sine?
be cos-
Cosecant, yes. So cosecant x. Or if we wanted to, we could change it back to cosecant t, since our answer is given in t, but the variable at the end doesn't really matter. Like if you notice, all the identities have u's in it. We could put u. On WebAssign, it'll matter because WebAssign's picky. So like if it gives you in t, you have to give the answer in t. But I won't be super picky about it. If you want to change it to x, change it to x. If you like it in u, change it to u. Any questions on this one? As you guys start to practice these, it'll get easier. You'll start to know what to do. You'll start to see how to simplify a little bit better. Ready for the next one? That we have here. All right. So example 6, we need to rewrite so that it is not in fractional form. So our goal is to get this to not be a fraction anymore. So we have to get rid of our denominator. So we have 1 over 1 plus sine x. What should we do to get rid of our denominator? What do you think? What can we do?
multiply the top and bottom by sine x?
So we could do that. If we multiplied the bottom by sine x, we would get sine x plus sine squared x. So it wouldn't really get us very far. if we had, let's think about this in terms of algebra. We had 1 over, let's say, 2 plus 3i. How would we get rid of this I in the denominator? We did this not too long ago. How would we get rid of the I in the denominator here?
Times it by 2 minus 3i.
Perfect. We multiply it by 2 minus 3i on the top and the bottom. So we multiply it by the conjugate to get rid of it. So on the bottom, let's multiply by the conjugate. What do you think the conjugate of 1 plus sine x is?
1 minus sine x.
1 minus sine x. So what we do on the bottom, we got to do to the top. So we're multiplying. On the bottom, we need a FOIL. So 1 times 1 is 1. 1 times negative sine x is negative sine x plus sine x minus sine x, sine squared x. And then on the top, we have 1 minus sine x. Everybody with me so far?
Yes.
Okay, we got 1 yes. Can we simplify this?
Could you cancel out 1 minus sine x on both?
Awesome. Well, no. We can't cancel out the 1 minus sine x on the top with the one on the bottom because there's more things going on the bottom. And it's being added. If it was being multiplied, we could cancel, but we can't just cancel those two out. But we can cancel this negative sine x and the positive sine x. Yes. So we have 1 minus sine squared x on the bottom. So we canceled out these two, the sine x, the negative and the positive sine x. Alright, let's look at our identities again. We see we have a sine squared x. So we want to look at our Pythagorean identities. Can we change 1 minus sine squared x to anything? We have 1 minus sine squared x. We can change this to cosine squared. I'm just rewriting it down here. What can I do next?
Can you make it into tan?
I can't make it into tan yet because I have this 1 minus, 1 minus up at the top. So in order to make it into tan, I need to break these up. So why don't we break them up and let's see where that'll take us. So we have 1 over cosine squared x minus sine x over cosine squared x. So when you break it up, you keep the same denominator, but I just split the top into 2 separate parts. Because if I simplified this part, I would get this. So I'm kind of going backwards a little bit to help me simplify. So let's look at our 1 over cosine squared x. Can that change to anything? Is that the reciprocal of anything?
Secant.
Secant. But since it's cosine squared, it would change to secant squared. So this 1 over cosine squared x became secant squared x.
And then does it become tan squared x?
Well, it would if we had a sine squared on top. But we only have one sine on top and cosine squared on the bottom. So let's change this into sine x over cosine x times 1 over cosine x. So I just broke this up, because if I multiply these two together, I end up with this. So I broke it up a little bit more. Now what's sine x over cosine x? Tan. So we have a minus tan x. And what's 1 over cosine x?
Secant.
Secant. Now we could simplify this more, but what's our question asking us? To rewrite it so it's not in fractional form. Do we have any fractions left in here?
Nope.
Nope. So we're done. So this is all we need to do. So again, I understand if you are a little bit lost. As you practice these, they start to become easier. It's almost like solving a puzzle.